intrigued on how you managed the LSU to be one of the zombie-less areas in the country.
Yes, Doctor. But unfortunately, we found out yesterday that there is already one infected person in the campus. Hello? Okay. And now, there's two of them.
But Professor, the rate of which the virus spreads is proportional to the number of infected people as well as the number of uninfected people.
14 days.
What?
It seems my mental calculations are correct. There will be approximately 14 days before half the population of the school turns into these mindless zombies.
Can you show me how you calculated that, Professor?
Sure. Since the population will not continue to grow because of the limited resources, then we are going to solve the problem by using the logistic equation. The logistic equation is equal to the change of x with respect to t equals to k times x times a minus x, where x is the population at time t, k is the constant of proportionality, and a is the carrying capacity. What we're gonna do first is plug in 13,000 to the equation. Then we're gonna separate it out. I'm gonna put all the x in the left side and t on the other. Now that we've got things separated out, we're just gonna integrate both sides. Okay, the right side no problem, the left side a little worse. We have to integrate it by partial fraction. What I'm gonna do is give each factor a fraction. We're gonna have a denominator x and the denominator 13,000 minus x, and on top we'll put a and b. And now we've got to figure out the values of constants a and b. I'm gonna multiply both sides by the denominator, simply to get rid of the denominator. If we do that, we're gonna have a times 13,000 minus x plus b times x equals 1. Let's see. If we let x is equal to 0, then a will be simply 1 over 13,000. Likewise, we can let x equal 13,000, and again, we'll get b is equal to 1 over 13,000. Since a is equal to 1 over 13,000 and b is equal to 1 over 13,000, we'll then have the integral of 1 over 13,000x plus 1 over 13,000 times 13,000 minus x dx is equal to the integral of the constant of proportionality. So the integration isn't bad. This just involves natural logarithms. So on the left side, we'll get ln of x over 13,000 minus ln 13,000 minus x over 13,000. On the right side, we'll get kt plus c. Again, we'll multiply both sides by 13,000 to get rid of the denominator. Remember, in the property of logarithms, we can write this as division. What we're gonna do next is exponentiate both sides to get the absolute value of x over 13,000 minus x equal to e raised to 13,000 kt plus 13,000 c. We then rewrite it to x over 13,000 minus x equals to c e raised to 13,000 kt. Alright, the next thing we're gonna do is get c. We can do this by letting t is equal to 0 and x is equal to 1. We can plug them in our newfound equation. As a result, x over 13,000 minus x is equal to c e raised to 0. We'll then get c is equal to 1 over 12,999. We are going to find k by letting t is equal to 1 and x is equal to 2. Again, we can do this by simply plugging them in from the earlier equation. According to my brain, k will be equal to 0.000053324. Since we already have our k and c, we can now plug them in from our equation. By using basic algebra, we'll eventually get our simplified equation to x is equal to 13,000 e raised to 0.693t all over 12,999 plus e raised to 0.693t. Now, all we have to do is plug in half the population to our equation. Again, we're just gonna use basic algebra, and eventually we'll get approximately 14 days.
My God! How can we stop this abomination?
I don't know, Doc. I don't know.